We all think we have a pretty good handle on common supplements, right? Vitamin D, for instance. Maybe you take it, maybe someone you know swears by it. But what if the real story behind it is way more complex? What if the science actually challenges some of those basic ideas we have about it? Welcome to the deep dive. Today we're really digging into vitamin D and calcium, specifically their impact on musculoskeletal health, especially as people get older. Our mission, we're going to unpack a really detailed source, the work of Dr. Bess Dawson Hughes. We want to pull out the most important stuff for you. Things like how vitamin D, with or without calcium, affects your risk of falls and fractures, and the mechanisms behind that, which are kind of surprising. Plus, how something like obesity actually complicates vitamin D management.
It's absolutely true. The information we're looking at today, it presents a much more, let's say, nuanced picture than you typically hear. It really does challenge some common assumptions. So yeah, get ready to maybe rethink a few things.
Okay, so let's start right at the beginning. Definitions. When we talk about vitamin D levels in a study, what are we actually measuring? What are the key levels?
Right, good place to start. The National Academy of Medicine used to be the IOM, Institute of Medicine. They set out some categories for 25-hydroxyvitamin D, that's 25-OH-D, in the blood. So deficient is defined as being below 12 nanograms per milliliter. That's quite low. Then insufficient is the range from 12 up to 20 ng-Elia. And if you're at or above 20 ng-Elia, you're considered replete.
Okay, 12 and 20 are the key cutoffs there. And what about falls? It sounds simple, a fall, but in research, how do they define that precisely? How do they track it accurately?
Yeah, that's actually super important. How you measure falls really matters. The Prevention of Falls Network, Europe, they came up with a consensus definition. It's basically an unexpected event where the person comes to rest on the ground floor or lower level. Yeah. But the key for accuracy is prospective daily recording.
Prospective daily recording, like a diary.
Exactly. A falls diary? Ideally checked in on maybe monthly to confirm the details. This avoids what we call recall bias. People just forgetting falls or getting the timing wrong if you ask them weeks or months later. It has to be consistent daily tracking.
Got it. So why is getting these definitions right and this whole topic, why is it so important for you, the listener, to understand?
Well, because falls and the fractures that often result from them, they aren't trivial. They have a huge impact globally on older adults' health, their independence. It can lead to serious injury, loss of mobility. It really affects quality of life.
Yeah.
So understanding the role of vitamin D and calcium here is, frankly, vital for prevention.
Okay, so we often hear vitamin D is good for bones, standard advice, right?
Right.
But here's where it gets really interesting and maybe a bit counterintuitive. Its effect on falls isn't just a straight line, like more is always better.
Absolutely not. That more is better idea is, well, it's one of the biggest misconceptions this research tackles. Early studies actually started hinting that there might be a kind of sweet spot for vitamin D levels to prevent falls.
A sweet spot.
Yeah. So, for example, one study found the lowest risk, the nadir region, they call it, was when levels were between 35 and 41 ng-Elia. And in another big trial, the Boston STOTAP IT trial, they also saw the lowest fall risk in a similar range, about 20 to 40 ng-Elia for people taking both D and calcium.
Okay, so an optimal range, not just higher, is better. But what happens when the doses get really high? Because some findings there seem to go the other way.
That's exactly it. It surprised a lot of people. Look at the Bischoff-Ferrari trial. They studied older adults who'd already fallen. The groups getting higher doses, like 60,000 IUs a month, they actually had more people fall, about 67%, compared to only around 48% in the group getting a lower dose of 24,000 IUs a month.
Wow, significantly more.
Yeah, and get this, the vitamin D levels in those higher dose groups were already around 40 to 44 ng-Elia, levels many would think are perfectly fine, even good. Then you have the Sturdy trial, almost 700 high-risk older adults. Even with daily doses from 1,000 up to 4,000 IU, they saw no reduction in total falls compared to a low-dose control. But here's the really concerning part. Injurious falls and hospitalizations with a fracture. They were actually higher in those groups taking the bigger doses.
Higher, not lower.
Higher. And another one, the Sanders KMM study in Australia gave a huge single dose once a year, 500,000 IU. That increased the risk of falling compared to placebo. So just cranking up the dose is clearly not the answer. It might even be harmful.
Okay, this really throws a wrench in the simple advice, doesn't it? Especially with all these different studies, some big, some small, some seeming to conflict. How do we even start to make sense of it all? Especially when you have these massive mega trials.
It is a huge challenge,
Mhm.
especially interpreting meta-analyses, where they try to pool data from lots of different studies.
Yeah.
Because you're often comparing, very different groups of people, different ages, health statuses, starting vitamin D levels,
Right.
different types of vitamin D used, different doses, different schedules.
Mhm.
Even the way they measure the vitamin D can vary. It's complex.
And those mega trials, like Vital, Vita, D Health, they sound definitive because they're so enormous.
They are massive, absolutely. Tens of thousands of participants. Vital had, what, over 25,000 people?
Huh.
And their size gives them statistical power, no doubt. But, and this is really critical, they were not primarily designed to study falls or fractures.
Oh.
They were looking mainly at things like heart disease or cancer.
Mhm.
And another key thing, many of them ran at the same time.
So they couldn't learn from each other.
Exactly. They didn't have the chance to adjust based on emerging findings from the other trials regarding falls or fractures. Plus, a lot of their participants already had pretty decent baseline vitamin D levels, like 25 to 30 ng/milliliter, and the doses they tested were quite high. And crucially, their methods for tracking falls, often just annual questionnaires, sometimes less, not those detailed daily diaries we talked about.
Which means the fall data might not be as accurate.
Potentially, yes.
Yeah.
It introduces more room for that recall bias.
So the takeaway is even a huge trial isn't necessarily the last word on every question, especially if it wasn't designed for it or used less than ideal methods for that specific outcome. That makes sense. Okay, let's pivot then. Let's talk about fractures, often the most serious outcome of a fall. Is the picture any clearer here? Do we see that same optimal range idea?
With fractures, yes, the picture becomes a bit clearer about when vitamin D and calcium definitely help. Take the Chapu study. This was in over 3,000 female nursing home residents. Very old, average age about 84, quite frail. Their starting vitamin D was really low, just 16 gillimil deficient basically. And their calcium intake was also low, around 500 milligrams a day.
Okay, so a very specific vulnerable group.
Exactly. And in that group, giving them 800 IU of D3 plus 1.2 grams of calcium daily made a huge difference. It significantly lowered their fracture risk.
That seems pretty clear cut.
It does. And similarly, the Estepra IT trial, remember, these were healthier, free-living older adults. Giving them 700 IU of D3 plus 500 milligrams of calcium daily also significantly cut down non-vertebral fractures. Their baseline D levels were higher, 26 to 33 in NLMR, but still in a range where supplementation showed a benefit.
Okay, so in people who are insufficient or deficient, adding both D and calcium seems to help reduce fractures. What about those megatrials again? Did they show any fracture benefit?
No, they didn't. Despite the massive numbers, Vital, Vita, and D Health found no significant reduction in fracture risk with the vitamin D regimens they used.
Which again points back to maybe the starting levels mattering a lot and maybe the dose.
Precisely. And it reinforces this idea of an optimal range, that U-shape again. There was a study by Bleicher K looking just at older men. They found that nadir region, the lowest point for fracture risk, was actually when 25 OHD levels were between 24 and 29 NDLE.
Wow, so quite specific. Not super low, but definitely not super high either.
Exactly. It strongly suggests there's an ideal window, not just more is better.
Okay, so we've got this fascinating pattern, this U-shape for both falls and fractures. Too little is bad, but too much seems bad too. This is probably the biggest surprise for many listening. What's actually happening biologically? What are the mechanisms causing this? Why isn't more just better?
Right, this is the really cool science part, the why. Let's break it down. First, low vitamin D, so being insufficient or deficient, under 20 ng/mPa. This directly impacts muscle. It seems to contribute to lower muscle mass. It can increase your parathyroid hormone, or PTH, which isn't great for bones either, and generally reduces muscle strength.
Okay. Weak muscles, poor balance.
Leads to falls and fractures.
Yeah.
Makes sense, right? There was a study by Pfeiffer M showing women with low D levels, under 20, actually improved their balance pretty quickly in just 8 weeks after getting both vitamin D and calcium.
So fixing the low levels helps muscle function and balance. Straightforward enough.
Yes. Now, the other side of the high vitamin D levels, say getting above 40 ng/mEO, this is where it gets really interesting. The main player here seems to be a hormone called FGF23, fibroblast growth factor 23.
FGF23.
It's an osteokine, mostly made by bone cells. And here's the kicker. High doses of vitamin D, especially over 3,000 IUs a day, or those big single bolus doses, they actually stimulate your body to release more FGF23.
So taking lots of vitamin D makes this hormone go up.
Exactly. And FGF23 acts like a brake, maybe too strong a brake, on your vitamin D system. When FGF-CON3 levels get high, it messes with vitamin D metabolism in the kidneys. It ramps up enzymes that basically deactivate both your stored vitamin D, 25-OHD, and the active form, 1025-OHD. And at the same time, it slows down the enzyme that makes the active form.
Whoa! So you could have high levels of the stored stuff showing on a blood test.
Right, your 25-OHD test might look great, even high.
But you don't have enough of the active form doing its job.
Precisely. You've got a full tank, like you said, but the fuel isn't getting to the engine properly. You have inadequate active vitamin D, 1025-OH2D, to support muscle and bone health, despite high storage levels.
That's quite a paradox.
It is, and there's more. FGF-23 itself seems to have negative effects directly on muscle. Higher levels are found in areas where muscle is wasting away, like in early ALS, and studies, like one by Beb and T, link higher FGF-23 levels to increased frailty in older adults.
So the whole cascade is too much vitamin D, high FGF-23, screws up active vitamin D, messes with PTH and phosphate, hurts muscle growth and strength, maybe calcium absorption too, leading to frailty, falls, fractures.
That's the leading hypothesis, yes. It ties together why those high doses, despite raising the number on the blood test, could actually increase risk.
That is genuinely fascinating, a real aha moment. Okay, let's zoom out a bit. We've gone deep into the mechanisms. How does this play out globally? We know deficiency is common. And what about obesity? That's a huge factor worldwide. How does that fit in?
Good questions. Globally, yeah, vitamin D deficiency is rampant. Levels vary hugely by region, sunlight exposure, diet, skin pigmentation, and calcium intake is also all over the map. Many places, China, Saudi Arabia, India, parts of Asia, have populations with both low vitamin D and really low calcium intake, often less than 500 milligrams a day.
Way below the recommended 1,300 milligrams for older adults.
Way below. So in those populations, like we saw with the French nursing home residents in the Chapoux study, combined supplementation could potentially have a massive positive impact.
Right. Now, obesity, it's a major growing health issue. How does that complicate the vitamin D picture specifically?
Obesity throws a couple of major wrenches into the works regarding vitamin D supplementation. We need to consider this, especially with projections showing, 60–69% obesity rates in the U.S. by 2050. It's alarming.
Okay, so what are the wrenches?
First, people with obesity generally achieve lower levels of 25-OHD from the same dose of supplement.
Why is that?
Two main reasons. Vitamin D3 is fat-soluble, so it gets sort of trapped or sequestered in the larger amount of body fat. There's also just more body volume, a dilution effect. There's even a formula researchers use. The change in your vitamin D level is related to the dose per kilogram of body weight. So heavier person, same dose, lower resulting level. A standard dose just might not cut it.
So dose needs might need to be adjusted based on weight. What's the second issue?
The second is it might take longer to reach a steady state, a consistent level, after starting supplements. Normally, it takes maybe 4 or 5 half-lives of 25-OHD, roughly 2 weeks or so for someone with a normal BMI. But obesity might slow down the activity of the main liver enzyme, CYP2R1, that converts vitamin D into that stored form. So it could take significantly longer for levels to stabilize in individuals with obesity. The Boston STOP-IT trial hinted at this.
That's really important for monitoring. You can't just test after 2 weeks and assume you're at your peak level if you have obesity.
Exactly. Clinical monitoring needs to take that potential delay into account.
Okay. This has been incredibly insightful, so let's try and boil it down. After this deep dive, what are the absolute must-know takeaways for our listeners?
All right, let's summarize. Core conclusion number 1. The link between vitamin D and fall risk looks U-shaped. There's likely an optimal zone, maybe around 20–40 ng/mL where risk is lowest. Too low is bad, but too high also seems bad. More work is needed on those exact boundaries, though, too. For older adults who are clearly low in both vitamin D and calcium, giving them replacement doses of both does significantly cut fracture risk. That seems clear. 3. High doses of vitamin D pushing levels above 40 ng/mL appear to actually increase the risk of falls and maybe fractures. More is not always better.
And the reasons for that U-shape?
At the low end, it's likely impaired balance and muscle weakness. At the high end, the main suspect is elevated FGF-23, messing with active vitamin D metabolism and potentially harming muscle directly via effects on PTH and phosphate. We also have to remember the global context. Widespread deficiency of both nutrients exists, which means targeted clinical trials using sensible replacement doses in deficient older adults living in the community are really needed. The results could have big policy implications, maybe even for food fortification. And finally, we definitely need a better handle on how long it takes for vitamin D levels to respond to supplements in people who are overweight or obese so we can monitor them effectively.
Wow. It really reveals such a complex interplay. Vitamin D, calcium, falls, fractures, FGF-23, obesity. It's so much more than just take a pill for strong
It
bones.
absolutely is. It really forces us, I think, to be more critical of simplistic health messages and really consider individual factors.
And for you listening, hopefully this gives you a much richer understanding of why a nuanced, maybe even personalized approach is so important. It's not just what to take, but understanding the bigger picture. So here's a final thought for you to chew on. Given this U-shaped curve and the huge impact of obesity, how might public health advice on vitamin D need to change? How do we move past a one-size-fits-all recommendation? And what role could personalized medicine play in optimizing bone and muscle health down the line? That's our deep dive for today. We really hope you feel much more informed about the surprisingly complicated world of vitamin D and calcium.
Absolutely. Keep exploring, keep asking questions, and keep learning.